Okay, so we're going to take a look at Boyles Law. Boyles Law has to do with temperature, and it has to do with pressure. So if you think about, pressure and volume. So if you increase the pressure on a gas, you are going to decrease the pressure. And if you're going to increase the volume, you're going to decrease the pressure. So let's take a look at a couple of things. So there's just a really cool story about a tunnel under the Thames, and workers would go to bed feeling fine but wake up paralyzed, and sometimes they wouldn't wake up at all. Ashcroft relates a story concerning directors of a new tunnel under the Thames who held a celebratory banquet near the completion, and when they opened the champagne it did not fizz, and as they came out of the tunnel, the champagne started to bubble within their digestive system. So I'm assuming that it was quite entertaining or a painful process to have gone through. But let's take a look at what actually happened. So if you take a look at Boyle's Law, here are particles in a gas. Again, there's no, they're moving very fast, randomly bouncing off the sides of the container. Here is a greater volume, so they're same number of particles, however, there is a greater volume. Here you have more pressure, so an increased pressure and a decreased volume. So here just showing that in a graph form. So as the volume decreases, the pressure increases. Okay. So here's just a little animation to show you that. So as you increase the pressure, the volume decreases. Okay, but you're keeping temperature steady. Okay, so you're not changing the temperature. We are going to put temperature in this whole mix in the next few lessons. So let's take a look at Boyle's Law. The volume of a gas decreases as surrounding pressure increases, providing that the temperature and the amount of gas remains constant. Another way of saying it would be the volume of a given amount of gas at a constant temperature varies inversely with the applied pressure. So increase the volume, you're going to decrease the pressure with the same. In other words, external pressures increases, gas molecules are forced closer together, so therefore the volume decreases. So here is the law. Make sure you write it down. You need to memorize this formula, where P stands for pressure and V stands for volume. P1 is the initial pressure, V1 is the initial volume, and P2 is the final volume, and V2 is the final pressure. You've probably heard about this, but especially if you are a diver, you've experienced this. If you go deeper down, your ears start to pain because you have increased pressure, and there's fluid in your ears, so therefore that pain, because now you are changing the liquids in your body. So there's and the air in your lungs, ears, and sinuses, and stomach, and your intestines undergo changes as well. So when a diver descends, the pressure exerted by the water on the diver causes the air pockets to squeeze, and the diver experiences the squeeze. They have to equalize the pressure by inhaling more air from the tank, because now they've, the volume in their lungs have decreased, and now they need to put more air into their lungs, so they can fill in all the spaces with gas. During the ascend, the pressure on the diver decreases, so they have to make sure that they are blowing out enough air so that they don't end up with this volume of gas in their sinuses and in their lungs. So they release these by just breathing out, exhaling as they ascend. So let's take a look at a couple of questions. So weather balloon that contains 35 liters of helium gas. And again, make sure you use the right units in your questions. If this was milliliters, you need to convert it to liters, okay? At 98 kilopascals, it released and rises into the atmosphere. Now, we know that going into the atmosphere, we're going to assume that the temperature remains constant, but we want to know what the volume of that balloon is, where the atmospheric pressure is 25 kilopascals, because the pressure decreases as you go up into the atmosphere. So let's take a look. We fill in all of our known facts, our pressure. So we want to know what volume is in the balloon. If just looking at this question, sorry, let me go back. Just looking at this question, do you think it's going to go increase or decrease the volume? So here we're decreasing the pressure. So my guess is the volume is going to increase, but let's just keep that in mind. Plug in all our numbers. Let's rearrange our equation. We want V2 on its own. So let's plug it all in. And you get 140 liters is what we expected, right? An increase in volume. Okay, so pause the video if you didn't get all of this to fill it all in, and tomorrow we'll work on our problems. Here's another, just make sure you do a therefore statement at the end. Okay, another question. So here, again, here's your milliliters, and here you have two different units for pressure, right? So now you have to convert one to the other. So again, you have 45.6 milliliters, 490 torsolini. So now we need to, and we have 3.00 atmosphere. Now, it doesn't really matter which one you convert, you just have to decide which one you want to convert, okay? But they both have to be the same units. Okay, so again, you're going to plug it, we're going to convert. I like using atmosphere just because it's what's common, and I can say atmosphere and most people know, but most of the time if you say torr to a commoner, a person on the street, they're not going to know what you're talking about unless they've taken chemistry, obviously. So let's convert it into torr, I guess. So here's our formula. We need V2, so we're going to divide this side by P2, divide this side by P2, so it should look like this. Let's substitute in our values and cancel out our units, and we should end up with 9.80 milliliters. And we can convert it into liters. So tomorrow at school you'll be working on worksheet 2.